In this video, I'm going to go over the linked list topics that we were talking about the week right before we went on spring break. I'm going to be reusing some of the slides I had before, so I'm not posting any new slides, but I will be drawing on some of them, so it'll be a little bit different than what we had in class. So just as a reminder, what is a linked list? Well, a linked list consists of objects, which we call nodes, that point to, not can, but do. So, that point to other objects of the same type. So, apparently my iPad is a different aspect ratio for some reason than these slides, so I'm going to have to figure this out. So, seriously? Okay. That do point to other objects. So an instance of one object can contain another instance of the same type. Or a node points to another node. So we normally draw this with little pictures as having a node, right? So this is an instance of our object that has a little pointer, right, to another instance, and so on. So this is an instance of some node class. Right. Okay. So not only do they contain these pointers, okay, but they contain some information. So we usually call that a payload, but so if this guy contains a 3 and this one contains a 7, right, those are the information inside the instances of the node. Sorry, these pictures got a little messed up. There's even one more bullet. This is used in cases a lot of times where we don't know the size of a list of things that we're going to be creating ahead of time, right? We might not know the length, so we want to store them in some non-length bounded thing, right? So an array has a fixed length. Arrays are fixed length, and linked lists are dynamic length. Right? So I went through this example in class, actually, that I thought was kind of funny, and I got it the day we were actually discussing it, but I was personally looking for the Twitter credentials for this Twitter account that I'm supposed to be managing. So I sent an email to the people that I knew, right, and said, "Hey, I need the Twitter credentials." Well, one of them responded. So I only knew my neighbors, right? I only knew those 3 people. I don't know anything about however many connections I'm going to need. One of the people replied, "Well, I don't have it, right? But I know this other person who might," right? Basically, Anath here said, "It's not in my payload, but here's my next pointer," right? And that went down the line. Umit was his next pointer, and Umit said, "Well, I don't have it in my payload, so I'm going to pass it down to Eckerman." Eckerman said, "I don't have it in my payload. I think May has it," or Mindy. And finally, actually, to end the story, which I didn't have at the time, Mindy did have the information. So Mindy's next pointer was null. Sort of normally, like I mentioned, we represent a linked list as this little picture, right? And it finally ends with this null pointer. And there's a couple way to add nodes to a linked list, right? So the first one is to append, right? Appending an element basically adds it to the very end. So that means so normally we have a pointer here, right? We know the first guy in our list. And then what we would do with appending is we would move that from here to its next, until next, basically you say let pointer equal pointer dot next while pointer dot next is not equal to null. Right? Once we get to that point, then we can say, right, that this is now pointer, or we could call it temp, or we could call it whatever we want to. And in that case, we say, so say we want to add element, some element to the end, then we basically say its next pointer is now no longer null. It points to this new thing we're going to create. And its next pointer is null. It's at the very end. Right? So that's called appending, right? You're adding it to the very end. The other way we can do it is prepending. So again, let's say we have our list and it has 3 things. And in this case, let's say that our initial state, we're going to call it list. And we want to add in this guy. And initially we make him and his pointer is null. Well, the way we do that is we break this. We have list point to our new guy, and our new guy's next pointer points to what used to be list. Right? Now we're prepending it. We're adding it to the beginning of the list. So now if you look at it, list points to the new guy, and then what used to be the first element, second, third, until it gets to the end. So we're prepending. So appending adds to the end, prepending adds to the beginning. We could also add them in order. So in this case, let's assume we had 1 and 4 and 7 were the actual payloads of our linked list nodes. And we want to add, so this is list. We want to add 3. Right? Well, in order addition is basically going to say you're going to move some temporary pointer until it figures out where it goes, right? And it's going to need to go between 1 and 4. So then we break this link and we add that link and that one. And now the list ends up staying in order 1, 3, 4, 7. Right? So that's how you add things either at the beginning, at the end, or in the middle somewhere. The next thing we might need to do to modify a linked list is to remove things. So let's assume again that we have some linked list. Right? And why do I keep doing that? Right, that points to null. Well, what if we wanted to remove so list. What if we wanted to remove this guy? Well, basically what we would do is remove that link and make it point to that, right? And we know the Java garbage collector, eventually nothing points to this guy, so it'll just get removed, right? What if instead we wanted to remove this guy? Well, in that case, we would basically just make that point to the second element. And once again, because nothing points to R, because we're going to, that link doesn't exist anymore, nothing points to R, so eventually the garbage collector will come and delete it. And then if we want to remove this last guy, right, well, basically all that's going to happen is this link goes away, and that points to the null character, and once again, garbage collection will take care of everything after that. Right? So that's how we add stuff, that's how we remove stuff. So let's go through a quick example. And here, the example that I was going through asked, what if we use a linked list to store strings, right? So normally strings are stored in some magical way that we don't actually know. But what if we used a linked list for that? So each element is going to contain a single character, right? And a link is going to go to the next character in the string. So I went through this construction actually in class. So I'm not going to go through the whole construction as it is, but we're going to walk through the elements that are here. So notice that our class, right? Our class contains a character and a pointer. So this pointer, this next thing, right, basically is another instance of our object, right? Our object class is myString, and it's an object of type myString. Our constructor, well, that's annoying. So our constructor here doesn't actually have to do anything, because if we're not given any information, then we can't put a character in the current instance, and we don't have anything. So initially, this is set to null, right? So the constructor that takes in a string, right? So we're assuming here that the string length is greater than 0, basically is a recursive constructor. And what it does is it pulls off that first character, right? So our current instance's character is the first character, and then it says, and then if the string length is greater than just this one character, I'm going to say that my next pointer is going to be a new instance with the rest of the string, right? I don't know in here anything other than the fact that the length of the string is greater than 1, right? I could ask, but I don't need to know how long the string is that's after me, right? Now, the other thing we did was we wrote a compare to function. So if you remember what string compare to does, is it returns a number that's greater than 0, right? Because usually we write something like, A, B, C dot compare to, and again, I'm abusing a little bit of notation, D, E, F, right? And that's going to be less than 0. Because ABC comes first. So that's what we're trying to do up here. But now we're not given a string as an array, we're given a string as a linked list. So we have our current instance, so we could call it this if we wanted to, right? But we don't have to. And we're basically saying, okay, well, if we've gotten here and our strings are not equal, right? If the current character is not equal, then just return a number that's less than 1 if I come first, greater than 1 if they come first. And you can't actually see it over here. But what it says is that's actually int of current, right? So we're converting a character into an integer, right? So the ASCII value is what we're looking at here. Okay, so if this fails, that means that our current characters are the same, right? If current is equal to other string.current, then we're going to do something else. Well, if my next character is equal to null and the other guy's next character is equal to null, that means we got all the way here and both characters are the same and we've run out of string to look at. Well, in that case, the strings match, right? And we return 0. Okay. Well, what happens if we're not at the end of one of the strings? Or we're not at the end of both strings? Well, if we're at the end of my string, right? Sorry. Yeah. So if we're not at the end of my string, so next is not null, and we're not at the end of the other guy's string, then we're going to run next.compare to other string.next. So we're basically, if we draw a little picture here, so I don't know how we got here, right? But something pointed to us. Something pointed to the other guy. So this is other. And that's this, right? So the first thing is if they're not equal, we do something. If they're both null, right, then we've reached the end and we don't have to go any further. If I am not null and he's not null, then we're going to run the same comparator, right, this and this. We're going to run it on this and that, right? And then if I'm not null, but he is null, right, then it's just whatever this value is what I'm returning, right? Because I know I'm bigger, so I must come after, right? Because I have more string and he doesn't, but we matched all the way up to here. On the other hand, if my next pointer is null and his isn't, then I must come first. So I need to return a number that's less than 1. Right? So that's what this last case says down here. So if we're both not null, then we're going to pass the buck to the next comparison. If one of the two of us is null, then I know the answer and I can calculate it. Okay? So that's the intro to linked lists. And in the next video, we're going to do some stuff about sorting on linked lists.